This is lecture 21 in network theory. So in this lecture we are going to discuss about the sinusoidal steady state analysis or SS analysis. So sinusoidal steady state analysis. Now in the previous lecture we have seen the DC transients and the Laplace concepts, right, in RLC network. In DC transients, right, so we will have source free, either RL circuit, RC circuit with source free and source for DC excitation. So DC transients, right? Now if I apply AC signal, so what we will get, what is the responses we will get, so that we need to see here. So this is a series, so there will be the current response I of t. Now to solve this one, so if I write the differential equation, what we will get, or the KVL across this loop, so I will get R into I of t plus L into di by dt is equal to V of t. Now if you see this one, so see, actually this is a V of t which is variable, right? Now that means we will get here for this solution, if we find the solution for this one, so it will have I of t is equal to complementary function or complementary solution plus particular integral. So generally this complementary function is called transient response, or we can say natural response. Similarly particular integral, or we can say steady state response or forced response, right? So the natural response generally comes by the DC sources and the steady state comes by from the AC sources. Now to find this complementary solution and particular integral, so we have to use different approaches. Now first we will find the complementary function, a solution, that is R into I of t plus L into di by dt is equal to 0 to find the complementary solution. So this can be represented, this is a single order differential equation, so it can be represented by a variable separable method. Di by dt is equal to R into I of t, so it will become 1 by I di is equal to R by, so it is minus R by L dt. If I take integration both sides, we need to place a constant k. So integration of 1 by x is nothing but log x or ln x. So ln I is equal to minus R by L into t. The integration of constant is t, variable will get plus k. But we need I of t, so it will, from this I of t or I of complementary function is equal to e power minus R by L into t into e power k. So that e power k I am assuming some constant a. So what is this complementary function we will get here is a complementary solution I of tr or I of t or t is equal to a into e power minus R by L into t. So what is this? This is a transient response. Why it is called transient response means after some time t is equal to is increasing, so it will be slowly died out, right? So it will be reduced to 0. So that's why it is called transient response, right? Always the transient response will become 0 when t is increasing, right? So this is the response like this, right? This is t, this is I t r of t. Now the practically when t is equal to 5 tau, so the transient response will become 0, right? So what is tau here for the RL circuit? It is L by R, right? So 5 tau, at 5 tau this will become 0 almost, right? This is about the transient response, but this is not our case actually. So sinusoidal steady state response. Now to find the steady state response, right, we'll have two different approaches. One is phasor approach, so this is very useful approach, and one is Laplace transform approach. right? So we'll do both cases. So first we'll do the phasor approach, then we'll do the Laplace transform approach, right? Now to find the steady state response, again I will take that circuit, which is R, and this is L, and this is V of t. Now we have to assume that to find the steady state response, this is I of t, so we have to convert into phasor domain, right? So before that we'll do time domain to phasor domain. What are the changes we'll get? Suppose there is a V of t, we'll get capital V. I of t means capital I. Similarly R means R only, but L means we'll get j omega L. What is the capacitor? 1 by j omega c, right? So these are the time domain and this is in phasor domain. And one more important, if V of t is equal to some Vm sine omega t plus pi, now in phasor domain it will become Vm angle pi minus 90 degree. Similarly, if Vm cos omega t plus pi is there, so this can be replaced by Vm angle pi, right? So what is this 90 degree means? Cos 90 minus theta is sine, right? Generally we take cos signal as a reference signal, so Vm angle pi, but if it is a sinusoidal signal is given, whatever the angle is here, pi minus 90 degree, right? Now when we apply this phasor domain approach, so this R and this L will become like this. So first case we'll assume sine omega t plus pi, so it is Vm angle pi minus 90 degree, this is R, and this will become j omega L, and this is I. Now what we need? I. So apply KVL. So KVL, so it is plus minus, so minus Vm angle pi minus 90 degree plus IR plus j omega L into I is equal to 0. Now what we need? I. So if I take I common, it will become R plus j omega L is equal to Vm angle pi minus 90 degree. So what is I here? We will get Vm angle pi minus 90 degree by R plus j omega L. Now to find the I of t, what we need to do is we have to find this is a complex, so we'll find the magnitude as well as the phase. Now the moment I find the magnitude and phase, Vm angle pi minus 90 degree, so magnitude is root of r square, real square and imaginary square, into phase, that is angle tan inverse imaginary part, that is omega L by real part R. Now this is a magnitude, so magnitude is Vm by square root of r square plus omega L whole square into angle pi minus 90 degree. If this angle is going up, it also will become minus tan inverse omega L by R. This is I. Now this is in phasor domain, so if we convert into time domain, so it will become like this. I of t is equal to, this is the magnitude, that is Vm by square root of r square plus omega L whole square sine, see it is pi minus 90. So what is the pi value? Pi minus tan inverse omega L. So omega t plus pi minus tan inverse omega L by R is the current response. This response is called steady state response. Steady state response. In the exam they will ask find the steady state response for the given circuit. So they will give the omega value and L value and Vm value, then we can find the current response or voltage response, right? The why we got this sign is because this is pi minus some value minus 90 degree. So if I write sine omega t plus pi in a phasor domain, some Vm angle pi minus 90, if this is the wave, then this can be written like this. So this is for sinusoidal signal. Now you do for cos signal, I will give some hint. So that is same R and this is L. Suppose this is V of t is given some Vm cos omega t plus pi. So in a phasor domain it will become Vm angle pi and this will become j omega L. So I am writing directly I is becomes Vm angle pi by r plus j omega L. Now if I find magnitude on phase, we will get Vm angle pi minus tan inverse omega L by r by square root of r square plus omega L whole square. This is I. Now how to find the response? Again I of t steady state Vm by square root of r square plus omega L whole square into sine. See, this is total angle, so it will become, sorry, not sine, it will become cos, because there is no minus 90 degrees. So cos omega t plus pi minus tan inverse omega L by r. So this is a steady state response for cos signal. Now what is the total response? Total response is equal to natural response plus forced response, or we can say I of t is equal to I transient response plus I steady state response. Transient response we got e power minus r by L into t plus Vm by square root of r square plus omega L whole square into sine omega t plus pi minus tan inverse omega L by r if it is a sinusoidal signal, and if it is a cos signal we will get this one as a steady state, that we can write. So this is the sinusoidal steady state analysis. Remember we will get transient response also, but the moment they ask what is the steady state response, so the transient response will become 0 after pi time constant, then only we will get the steady state response, which is this one, right? So this is how to find the steady state response. Similarly we will so just pause the video and do for RC network, right? I will give RC, so you pause the video first, then find the responses, then I will get the value. Suppose there is a R and C, and here suppose V of t. Now V of t I am taking some Vm cos omega t plus pi, right? So find the current response I of t. So in phasor domain, so what is this one? So it will become R, and this will become 1 by j omega c, and here Vm angle pi, right? So this is I. Now I can write simply I is equal to Vm angle pi by r plus 1 by j omega c. Now if it is 1 by j omega c, it will become angle pi by r minus j by omega c. Now if I write magnitude and phase, so Vm angle pi by square root of r square plus 1 by omega c whole square angle is, see, imaginary part, that is tan inverse, imaginary part, that is minus 1 by omega c by r, so 1 by omega c r, right? So this will become minus tan inverse, right? Imaginary part is at the fourth quadrant, so this will become Vm by square root of r square plus 1 by omega c whole square angle pi plus tan inverse 1 by omega cr. So this is I. Now what is the steady state response? I steady state of t is equal to Vm by square root of r square plus 1 by omega c whole square into, so we have taken cos, so we will get cos, so cos omega t plus pi plus tan inverse 1 by omega cr. These are the two RC and RL network, so we can get the steady state response using phasor domain. So steady state analysis, suppose question is given like this. This is 1 ohm and this is 2 Henry, and here is given as 2 sin t. Find the steady state current response, suppose if it is given like this. Now using the phasor approach, first we need to find the omega value, right? So what is omega here? So it should be compared with sin omega t. So omega is equal to 1 radian per second. So the circuit will become 1 ohm, and this will become j omega. Omega is 1 into L. L is 2, and this is represented like this, 2 angle. So what is sine omega t plus 0? 0. So 0 minus 90 degrees. So that means 2 angle minus 90 degree. And this is I of t, or capital I. Now how to find this one? Apply KVL. So what will you get? 1 plus j2 into I is equal to 2 angle minus 90 degree. So what is I? 2 by 1 plus j2 angle minus 90. So what is this magnitude? So 2 by square root of 1 plus 4, and angle tan inverse 2 by 1. So this will become 2 by root 5 angle minus 90 minus tan inverse 2. Right? So this is I. Now if I convert into time domain, I of t will become 2 by root 5 sine. See, this is the minus 90. So 0 minus 90 means sine omega t, that is sine t minus tan inverse 2. Right? This is the response. Similarly, any capacitor or inductor, anything is given, first we will find the phasor domain diagram, then we can find as like this. Right? Very simple. You can do 2-3 problems on this. Right? So that is steady state analysis, means always we have to find either ISS of t, or if it is a parallel RL circuit or RC circuit, we will get VSS of t. So I will give question for you, you do it. Suppose there is a current waveform 2 cos 2t, and there is a parallel RL, that is 1 ohm, and this is a inductor 2 Henry. Find the V of t, steady state response V of t. So VSS of t we need to find, and this is the question 1. And the question 2, suppose this is simple RC circuit, 1 ohm, 2 farads, right? And this is current is again 2 sine 3t, right? Again find this V of t. So I will do one, you proceed for the second. So first, what is this? From this, omega is equal to 2 radian per second. Now it will become 2 angle 0 degree, right? Because it is, what is the angle here? So 0 omega t plus theta, so only 0 degree. So it will become like this. So this is 1 ohm, and this is j into omega. Omega is 2 into 2, so it will become 4j. Now this is V. Now apply nodal analysis. So if I apply nodal analysis, what I will get? 2 ampere is incoming, so minus 2 angle 0 is leaving, plus V by 1 plus V by 4j is equal to 0. If I take V common, 1 plus 1 by 4j is equal to 2 angle 0. Now how to proceed? So V, if I take common, 1 plus 4j by 4j is equal to 2 angle 0. So V is equal to 4j, 2 angle 0 into 4j by 1 plus 4j. Now if I write in the magnitude and phasor, j means the angle 90. So 2 angle 0 into 4 angle 90 by square root of 1 plus 16 tan inverse 4, right? So this is 8 by root 17 angle 90 minus tan inverse 14, right? So 14, no, it is a 4, tan inverse 4. So this is V. Now we got 90 minus tan inverse 4. If you use the calci, you can get tan inverse 4, but we can directly write V of t, steady state response. V of t is equal to 8 by root 17 cos, because cos signal is given, cos 2t plus this, whatever the angle is there, so 90 minus tan inverse 4, right? So we can use the suppose this response is not there in the options, we can use cos 90 plus theta. Cos 90 plus theta is what? So this will be in second quadrant, so all sine and cosec, right? So we'll get minus 8 by root 17 sine 2t minus tan inverse 4. So either this value or this value. So same as we have to do this problem, so do it on your own and find the value of v of t, right?